Welcome to video 6 on my off-grid solar energy project. I've got some upgrades and changes to talk about. First are a few software settings in the Magnum inverter that I call resilient mode. Active balancers were added to the lithium iron packs, and I'll explain why that's needed. I also have 2 extra panels from this project, and I added them to help charge the battery using low-cost equipment until I can figure out what to do with them. Lastly, I'm trying to solve how to use the excess power that my solar panels will generate in the summer. In addition to load shifting for high loads to the afternoon, I plan to use the excess power for my central air conditioner. While I don't have a final solution in this video, I'm working on something that is going to do it. Here we see the Magnum ARTR screen in the inverter setup. I'm showing that to have lots of energy saved up in the battery, I need to increase the voltage levels so that its reserve power is saved in the battery. I move the connect voltages from 46.8 to 49.2 and the disconnect volt from 48.8 to 52 volts for a 15 series lithium iron battery. In energy maximize mode, I have the battery go nearly dead every night, and in the morning switch to solar as soon as there's 1 kilowatt hour in it. So it's always trying to keep the battery low so it can absorb the most sunlight as possible in the middle of the day. If the battery's half full, it would fill up in 2 hours of sunlight, where it would take 4 hours if it's flat. It's possible to charge the battery with the grid using the Magnum's built-in 60 amp charger. It'll draw almost 3,500 watts from the grid when it's set to the 100% charge rate, which my natural gas generator can also provide. I've had issues with my lithium iron phosphate batteries. Over the course of a few weeks with my keep the battery low strategy, one of the 15 cell layers started to drift out of balance and below 2.5 volts. It had been a few weeks since it was fully charged, and one of the cell layers had drifted to the point where the BMS cut the power. It only took 1.5 amp hours to bring the low layer back into balance, so I knew it was a small problem, and the solution is to always be balancing the battery. There are new products out there just for this problem, active balancers. I have the 5 amp capacity ones here with the red capacitors. The 17 series ones go for $55 shipped on eBay. They don't isolate the battery, however, so a top balancing BMS is still required. Both are required for the batteries that don't get top balanced once a week. So I have these 2 extra panels, 295 watt each, and it's a shame to have them just sitting around doing nothing. So I made a 2-axis tracker frame for them, and at a later time I'll automate them, but for now I screwed them to my old picnic table. I have a small DC disconnector on there and hinges that will be needed for elevation changes. To put the energy into the battery, I have the infamous MPT 7210 charge controller. There are lots of videos about this, so look that up, but I can collect 2 kilowatt hours with this in these panels. I can say that the per panel energy collection is about half that of the EP-Ever controller, so I'll get rid of this cheapo deal and install another high quality MPPT controller that's better. The 7210A is good for charging the battery with a AC to DC 54 volt 10 amp power supply if I don't want to mess with changing the settings in the Magnum. Resilient mode light, I call it. So on to the HVAC upgrades. I bought 2 of these energy efficient motors that use a lot less power from a company called Mars. A 1/2 horsepower one for the furnace blower and a 1/3 horsepower one for the outdoor condensing unit. These are so-called rescue motors that HVAC techs can keep on their trucks so that they can get someone up and running quickly if they don't have the exact match parts. They also happen to save much energy compared to a typical permanent split capacitor motor. These 2 motors will save 33% of the energy used by my central air conditioner when it's running, which is the same thing as upgrading from a 10 to a 15 EER air conditioner or a 12 to a 25 SEER. The Mars blower has an auto sizing feature, and after that was done, it resulted in the blower moving 15% more air in my furnace, all while using 800 volt amps less. This is the outdoor condenser fan motor. It was also replaced with the Mars ECM motor. When this is done, the large multi-tap capacitor fan connection will go unused because the ECM motor doesn't need a run capacitor. My outdoor condenser has a contactor, but only one leg of the 240 volts is interrupted, so I'll be installing a proper 2-pole relay to interrupt all the power in the outdoor unit. So that takes care of 2 of the 3 main motors in a central air conditioner. That leaves the refrigerant compressor. My first idea was to reduce the peak current draw of the compressor pump when starting by installing an industrial motor soft starter. There are a few available for 1-phase motors, and I bought what I thought was the best one. After a short test period, I was able to reduce the startup current draw from 137 amps 240 to 86 amps 240. The only problem is that 86 amps is still too much for the Magnum to provide all up by itself. It can only give 40 amp surge, and that's under perfect laboratory conditions. The Magnum inverter can easily power the AC unit once it's up and running. It only needs 9 to 10 amps, just not when it can start. So I have come up with another plan, and I'm going to try it out, and maybe I'll use this soft start for a window air conditioner or a dehumidifier or something. The Magnum can provide a much larger surge current on 120 volt loads compared to 240 volt loads. Thanks for watching, and go solar.